Hi everyone, welcome back to class of inferential statistics. Today we will discuss on theory of statistical tests, part 1. The objective of a statistical test is to test a hypothesis concerning the values of one or more population parameters. We have null hypothesis and also alternative hypothesis. In this case, the null hypothesis is denoted as H0. Our alternative is denoted as H1. We also have one-tailed test and also two-tailed test. So sometimes this one is called as one-sided or two-sided test. So one-sided test is when we have alternative is theta less than or theta greater than theta naught. While for two-sided test, we will have the alternative is theta is unequals to theta naught. Two-sided test, that means we have two rejection region. While for one-sided test, we only have one rejection region, or one way how we can reject the null hypothesis. A statistical hypothesis is an assertion about the distribution of one or more population parameters. So in this case, our parameter, it can be parameter mu, our population mean, parameter sigma, our population standard deviation, parameter sigma square, which is our population variance, and also parameter pi, which is our population proportion. So we can have difference between two population, or we can take ratio of two population. So if the statistical hypothesis completely satisfies the distribution, it is called as a simple statistical hypothesis. For example, if we have our H0, theta equals to theta naught. So this one is called as a simple statistical hypothesis. If the statistical hypothesis does not completely satisfy the distribution, it is called a composite statistical hypothesis. In this case, we will have our null hypothesis can be written as theta less than or equals to theta naught, or it can be also theta greater than or equals to theta naught. So what is the element of statistical test? We have the null hypothesis, which is the null hypothesis is the hypothesis to be tested. Alternative hypothesis is the hypothesis to be accepted in the case when H0 is rejected. So that means once we reject our H0, we will accept our alternative hypothesis. Next, we have the term for test statistic. Test statistic is a rule when the experimental values have been obtained, which leads to a decision to accept or to reject the hypothesis under consideration. For example, our test statistic, it can be either z-test. So if we have z-test, it can be written as x bar minus mu over sigma over square root of n. Next, we have the term critical region or rejection region. The region associated with a test statistic is the other function part of a statistical test. It is the set of values for the test statistic that result in the null hypothesis being rejected. For example, let's say if we have alpha equals to 0.05, we compute z alpha, we will have 1.6449. So this value is from our stats table. So this at alpha 0.05, this one is our critical value. So what is our critical region? Critical region, let's say we have normal curve. So this is our z alpha, which is 1.6449. So this is our critical region. Let's say if we have the alternative is theta greater than. So we will reject H0 when our z-test is greater than z alpha. So this one is our critical region, or is so called as rejection region. Okay, next, let us refer to type of errors. We have type 1 error and also type 2 error. So what is type 1 error? Type 1 error is rejecting H0 when H0 is true. Probability of making type 1 error is alpha. Okay, while type 2 error is accepting H0 when H0 is false. Or in other words, we can say when H1 is true. So probability of making type 2 error is beta. Okay, so in this case, we have type 1 error and also type 2 error. So type 1 error is referred to probability of rejecting H0 when H0 is true, while probability of making type 2 error is accepting H0 when H0 is false. So both are the errors when making a conclusion based on our test statistic. So if we choose a very small value of alpha, we will be making it very difficult to reject the null hypothesis, where our type 2 errors will be common. For example, let's say we find alpha 0.05. Okay, alpha 0.05. We get the value of Z alpha is 1.6449. If we compare alpha 0.1, we will have alpha 0.1. In this case, we will have, so alpha 0.1, we have 1.2816. So if we compare the area of our rejection region, okay, we will have so this is 1.6449. So this is 1.2816. Okay. So if our Z test is greater than Z alpha, so we will reject H0. So this one is for alpha 0.05. But when we increase alpha 0.1, it will become, this one is our area, alpha 0.1 rejection region. So that means if we choose a very small value of alpha, it will be making it very difficult to reject the null hypothesis. Okay, where our type 2 errors will be common, since this is the rejection region, while we will have the acceptance region is over here. Okay, so this is our acceptance region. Okay, so but if we have alpha 0.1, okay, alpha 0.1, so probability of making type 1 error is increasing. Okay, so we will have a larger rejection region compared to alpha 0.05, and the type 2 errors will be less. So if we choose a large value of alpha, type 2 errors will be less common. Okay, so since the acceptance region is reducing.